Hi, in this video we're going to look at another problem here, and this problem is to figure out what's the best algorithm to use for finding whether or not two strings are anagrams. They would be anagrams if both strings have the exact same characters in them. They can be in different orders, but they have the same ones. Okay, so an example would be earth and heart. They both have the same letters in there, they're just in different orders. Okay? So I've got four different solutions for how to do this. So we're going to start off with the first one. And what the first one's going to do here is we're going to take the two strings and then we're going to compare the letters in one string to the letters in the other one at a time, to see if they all match up. Okay? So let's get started here. And I got a lot of stuff opened up on here, so let me find where I am. There we go. So I'm going to open up a new folder here, new file, and we'll get started on putting this in here. So we're going to do DEF anagram solution 1. We're going to pass in two strings, S1 and S2. Okay. Actually, I want to. Okay. So we're going to create a list, and it's going to be equal to list S2. So we want to convert S2 into a list and store it in there. We're going to do position 1 is going to be equal to 0 to start with, and we're going to do a still okay is going to be equal to true. So as long as everything's good, we'll keep going. So now what we're going to do is while nope, that's right. Yeah, while position 1 is less than the length of our S1 string and still okay, we're going to set position 2 equal to 0, and we're going to set found equal to false. Now what we're going to do is while position 2 is less than the length of our A list and not found, oops, go. If S1 position 1 equals A list position 2, then found equals true. Else, we're going to set position 2 equal to, I'll just do it this way, be easier, plus equals 1. Add 1 to it. Once we get done with that while loop, we're going to check to see if we found it. Then we're going to set A list position 2 equal to none. Else, we're going to set still okay equal to false. And then go position 1 plus equals 1. And then since we're done with all this, then we're going to return still okay. So let me go through this with you real quick. So we're going to take, while position 1 is less than the length of our S1, and we're still okay, so we're going to look at each one of these. Okay, so we're going to take each one of the position 2 values and compare it to position 1, each one of the A list, and compare it to position 1 of our first string. Okay, if the position 1 is equal to A list position 2, we found it and it's true. Okay, as long as we find one of them that turns out to be true, then we're good. Okay. If not, then we continue on. If we never find it, it stays as false. As be down here, then we set still okay to false and drop out because we didn't have a match. As long as we keep finding them, then we're good. If we find it, then we want to mark that position as none in there so that it's no longer available to compare to anymore. Okay. So let's do our main part of this. So we're going to print right here, there we go, anagram solution 1 for strings A, B, C, D, type them in right, and D, C, B, A. Okay. Then we're going to print anagram solution 2 for A, B, C, D, and D, C, B, E. Oops, I could leave the 3 in there, but that's okay. D, C, B, E. So I'm going to go ahead and get this saved. And I'm going to call this anagram01.py. Save that, and then we'll run it, see if I got any errors in here. Yep. Okay, misspelled something on one of these. Get this down out of my way here so I can find this over here. Oh, this should still be anagram solution 1 here. That's what it was. Okay, run it again. First one's true, second one's false, so that worked, no problem. Okay, so that's the first one. What we're going to do is we'll do these and then we'll compare them to see which one may be the best solution. Okay, so let's go to number 2. So in this one, we're going to make use of the fact that even though S1 and S2 are different, they are anagrams only if they consist of exactly the same characters. So if we begin by sorting each string alphabetically from A to Z, we can end up with the same string if the original 2 strings are anagrams. Okay, so let's do that. And what we're going to do is we're going to sort these strings, and then we can compare. Just all we have to do is compare to the to each other, and they would be anagrams if they all match. This is anagram solution 2, passing in S1 and S2. So we're going to convert both of these into strings. So we're going to do our A list 1 is going to be equal to list of S1, and A list 2 is going to be equal to list of S2. And we want to do is sort these. So we're going to do A list 1 dot sort and A list 2 dot sort. I'm going to set position equal to 0. Whoops, there we go. And matches equal to true. So now while position is less than the length of S1 and it still matches if A list 1 PO position equals A list 2 position, then all we want to do is position plus equals 1. Else, we want to set matches equal to false. And that way we can drop out of the while loop right here then. So all we have to do is return matches. And then we're going to do a couple of we're going to print anagram solution 2, passing in A, B, C, D, E, F, and F, E, D, C, B, A. This reverse order doesn't make any difference on that. Parentheses there. Then we're going to print anagram solution 2, again, C, D, E, F, and F, E, D, X, B, A. Doesn't make any difference. We just need to have them be different. And that's a quote mark right there. There we go. Okay, so I'm going to go ahead and get this one saved. Do a file save as. This one I'm going to call anagram o2.py and save it. Okay, and then we'll run it. I've got an error there. Not sure why. Let me back this out of here. Try it again. Cannot assign a subscript here. Okay. Don't know why it's saying that, because a list 1 is a list just right there, and a list 2. Oh, that's it. I should be 2 equal signs there. Okay, I should have read the whole thing. Let's run it again. First one's true, the second one's false. So that one worked also. Okay, so now we got two that work. The third one, we're not really going to write a code for, and I'll explain that here in just a second. The third one is called brute force, and what that does is it takes the two anagrams and creates every possible value of them, and then compares them to see if they work or not, if they're the same thing. Okay, so the problem with this is that when you start getting into large numbers of characters, it increases exponentially. So if we had 20 characters, actually it's a factorial value. If we had 20 characters, it would be 20 factorial on how many we would have to do on this. And that comes out to be, let's see, hundreds, thousands, millions, billions, trillions, and what the next one is after trillions, 432 of that times, and it would take forever to do this. In fact, if we did this every second, we did one of these possibilities every second, it would take us hundreds, thousands, millions, over 77 billion years to complete it. So we're not going to do it. We don't have enough time to do that. But we are going to go to solution 4. And solution 4 is account and compare. Okay, so this takes advantage of the fact that any two algorithms will have the same number of A's, the same number of B's, the same number of C's, and so on. So in order to decide whether two strings are anagrams, we will first count the number of times each character occurs. Since there are 26 possible characters, we can use a list of 26 counters, one for each possible character. Each time we see a particular character, we will increment the counter at that position. In the end, if the two lists of counters are identical, the strings must be anagrams. So let's go ahead and create this one. Do a new file here again. And okay, so over here with my mouse, there we go. Anagram solution 4, S1 and S2. Okay, so we're going to create C1 equals so it's going to create a list of 26 locations, each of them storing a value of 0. We're going to do the same thing for C2. And what this does then is it creates two lists, 0 through 25 for the 26 letters in the alphabet. Each one has a position that has a value of 0. So we just add 1 to each of these every time we find one that matches. So for I in range, the length of S1 and then position equals the ord of S1 sub I minus the ord of A. We're going to do this, make sure that this is in lowercase letters. So what we're doing is it's going to take the ASCII code for A, lowercase a, which is 97, and this should be a minus here, and subtract that from the ASCII code for the character at this location. So let's say the character is B, then it would subtract 97 from 98, which would give us 1. And so when we get, so the position then is going to be 1. So we would add 1 to C1 sub 1. Okay, so that would work for all the letters then. And so C1 sub position is going to be equal to C1 sub position plus 1. Okay, or a better way to do it would be plus equals 1. There. Okay. And then we're going to do the same thing again for I in range. The length of S2 position is going to be equal to the ord of S2 sub I minus the ord of A. Now, this only works for lowercase because that's the way we have it set up. We could set it up as doing dot lower Arnhem to make them all lowercase just in case, but since we're doing this and we're going to test it, we'll just make sure we have lowercase letters in there. And then C2 POS, type the right letters here, POS plus equals 1. Okay. So now we're going to set J equal to 0. Still OK is going to be equal to true. Then we're going to run through a while loop. While J is less than 26, the number of locations we have, number of letters in the alphabet, and we're still OK if C1 sub J equals C2 sub J, then J plus equals 1. Else still okay, is going to be equal to false, which would let us drop out. And then we just return still okay. Okay, then our main, we're going to print anagram solution 4. Do an A, B, C, D, and I'm going to mix these up and do C, B, A, D, and D, C, B, A. And then we're going to print anagram solution 4, and we'll do C, B, A, D again, and then we'll do E, F, B, C. Okay, so that they're different. Okay, so let me get this saved. This is going to be saved as anagram 04 because we skipped 3. Remember, we're not doing 3 because it would take way too long to do that. And let's see if I got any errors in this one when I run it. Yep, right there. Should be a minus there. Let's not hit the key. And we get true and false. So that worked also. So now what we want to do is we want to analyze these. So let me pull these over. Let's see. Let's start with solution. Is it here? Yep, solution 1. And I'm just going to kind of talk through this. Okay, so we have 3 lines here, so that's a 3. We can discard that. This has a nested loop in here, and we have to always do the worst case scenario on this. So the nested loop is going to run, the outside loop is going to run the number of positions we have for S1. Inside loop is going to run for the number of positions we have for for the A list, which is S2. We're going to assume that they're going to be the same length, because if they're not the same length, then it's already automatically not anagrams. So that would take this one times this one. So we could say like M times N on that, but it's going to be, or N times N, because it would be the same one. So that's going to be N squared. Okay. So we get all the way down. Okay, we can talk. So there's two in here. Those gets discarded. The if statement, both if statements are going to get discarded out of there, and then this one here also in the return. So we end up with N squared. Okay, so it's going to be O of N squared on this one. Okay, so let me get rid of that one there, and then we'll do this is anagram 2. We'll analyze it. Okay, so we have 1, 2, 3, 4, 5, 6 lines there. So those get discarded because they're constant and we don't need that. And here we just have a while loop. The while loop is running for the length of S1 times, and so that's going to be N, and that's it. So this one's going to be N. Okay, sounds good at the start, but both lists have to be sorted. And I don't know what algorithm Python uses. I'm guessing that uses a fast one. But if it uses, and we haven't done sorting techniques yet, but if it did a sorting technique that was N squared, then this is going to be N squared rather than N. So it depends on what that is there, on whether or not, on what it is. Okay, so let me do that one, then we'll do this one here, which is our 4. And on this one, make this a little bit down more. Let's maybe I can get this whole thing on here. There we go. Okay, so that's 2. Doesn't count. This is the length of S1, and then this is a separate one that's the length of S2. So those are both going to be N. Okay, so we have 2N right now. Okay, and then these are ones inside here, so those don't matter. This is 1, this is 1. And then this is going to be 26 times, no matter how large N is. So this is going to be 20. So this is going to be 26. Okay, so that is discarded also. So what we end up with is N on here. So, or 2n, and then the 2 is discarded because it's a constant, so we end up with n. So this is an ON. So this is actually the best one of the 4 algorithms on here. So that's why you want to evaluate your algorithms, because sometimes you can come up with an algorithm that's going to be quite a bit faster. So hope you got something out of this, and keep watching videos. I'll have some more over this material as we go along. Bye.